Ladies and gentlemen, we've received unprecedented visuals and previously unseen signals at the same observation panel, prompting us to confront a question that remains largely unanswered. What, precisely, is Atlas? Over the past few weeks, three components have come together, forming a perplexing puzzle. Firstly, recent images reveal an ongoing structure accompanied by a massive end. Secondly, there are reports of a forward jet exhibiting surprising collimation. Thirdly, a collection of temporal signals, including gamma-ray burst observations, has emerged. Moreover, we possess measurements that do not conform to the conventional comet model. When we consider all these factors together, the notion that this is merely a comet starts to diminish in credibility, especially given the mounting anomalies. We should approach this seriously, balancing scientific authority with technical challenges. When an average observer spots something unusual, it becomes just another piece of curiosity. However, when a respected astrophysicist publishes a series of observations and calculations that quantify minuscule probabilities, the dialogue elevates to a different realm. It transforms from mere interest into a genuine scientific inquiry. Vibe and colleagues have documented numerous geometric coincidences, figures, and measurements that, when considered individually, may raise suspicions. Yet, collectively, they begin to construct a case that is hard to overlook. The critical insight here is that some of the observed characteristics have very slim chances of occurring by random chance if we're indeed dealing with a standard comet. The extreme collimation of a jet oriented toward our Sun, its consistency before and after perihelion, and the alleged apparent axis shift all contribute to making a natural explanation improbable. When someone quantifies this, as Liu has done, the implications are clear. The suggestion of a purely natural entity weakens against theories that weren't serious consideration. What the images and brightness maps reveal are concrete observations. In visuals gathered from multiple telescopes between December 14th and 16th, 2025, a sunward antitail is distinctly noticeable, extending toward our star. Recent measurements indicate that this antitail maintains collimation over distances of approximately 500,000 kilometers, which is comparable to, or even exceeds, the average distance from Earth to the Moon. Brightness maps, processed using filters like Larsenina, reveal a linear, narrow, and coherent structure that is significantly longer than it is wide. Additionally, wide-field images captured on successive nights show consistent orientations. The antitail maintains an angle very close to the sunward direction, and brightness profiles permit precise angular measurements indicating a narrow opening of approximately 6 to 8. These details suggest that we are witnessing an extensive, relatively stable physical structure encompassing the nucleus. Rather than mere projection errors or camera artifacts, now let's address the oscillating movement, the wobble that complicates matters further. More than just a long tail, it was the periodic modulation observed in the angle of the antitail during July and August 2025 that attracted attention. Measurements indicate a wobble period of about 7.74 hours, plus or minus 0.35 hours, implying that the jet's launch point is misaligned by a few degrees concerning the rotation axis. Essentially, the jet traces a cone as the body rotates like a lighthouse beam rotating in a small circle. What makes this significant is the geometric implication. If the jet's base lies less than 8 from the rotation pole and its axis, when projected into the sky, points nearly toward the Sun, it appears that the jet's alignment is curious. According to Liu's calculations, the likelihood of this fortunate alignment occurring by chance is around 0.5%. When we factor in the necessity for a corresponding jet at the opposite pole after perihelion, the overall probability plummets to about 25 millionths. In simpler terms, this represents an exceedingly unlikely coincidence. Moving on to the persistence of the forward jet collimation and the intriguing golden blade. Both amateur and professional observers, including Dan Bartlett, Tony Scarato, and Therese Thiawong, have meticulously described a forward jet that resembles a blade. Strangely, it remains oriented in the same solar direction, post-perihelion. Beyond its visual characteristics, numerous reports expressed observing a golden hue and a narrow blade. Studies confirm that the jet's collimation remains within 6 to 8 over distances ranging between 500,000 and 1 million kilometers. Such consistency is unexpected, as solar winds and radiation pressure should easily cause a long jet to widen or be deflected. Another notable coincidence is that the gravitational deflection at perihelion was calculated to be around 16.4, precisely double the jet's opening angle. This opens the geometric possibility that a jet cone directed at one pole before perihelion has its counterpart at the opposite pole after perihelion. Liu emphasizes this as a remarkable pattern, not merely coincidental. In layman's terms, the jet configuration before and after perihelion appears to correlate with the angle of gravitational deflection. Now we come to the statement that sent chills down many spines. Evidence suggests that the object's rotation axis seemed to shift direction after perihelion, or, at the very least, The jet pattern and the behavior of the projected axis in the sky imply that something in the object's geometry altered in a way that cannot be simply attributed to thermal conduction or the sublimation of ice pockets. Observers describe a turn and an adjustment in trajectory that some interpret as a maneuver indicating active control over the propulsion vector. The physical aspect is vital. If the jet's base was operational before perihelion and then went dark in that area afterward, a natural dissipation explanation would necessitate another ice pocket almost symmetrically situated at the opposite pole, both thermally insulated for months to prevent conduction. Liu categorizes this as a challenge for natural explanations. The alternative would suggest thrusters or some sort of technological system deliberately expelling mass in a targeted direction, say, toward the star in our solar system. This hypothesis could elucidate maneuvers, adjustments to the axis, and the persistence of collimation, even against solar winds. Amateur observations, including stacking homemade images, minute variations in brightness, and reports of jet wobble, contribute empirical support to the discourse. This is not merely a theoretical framework. Real effects have been observed and measured in the sky. Nonetheless, definitive proof hinges on spectroscopy, high-resolution imaging, and ongoing monitoring. To recap, here are the 15 known anomalies of Atlas. Before rendering a judgment, it's beneficial to clearly outline the anomalies that factor into the debate. While counts may differ, I present a consolidated version based on Liu's writings: geometric and orbital. Retrograde trajectory nearly in line with the ecliptic plane. Probability approximately 0.2%. Timing and fine adjustments to specific distances to Mars and Jupiter appear deliberate. Predicted proximity to Jupiter indicates an orbital objective. An unusually columnated sunward and the rotation axis aligns with the sun's direction within about 8 with a probability of 0.05%. Periodic jet wobble of 7.74 hours, only explicable if the base is less than 8 from the pole. Jet appearances before and after perihelion contain improbably geometrical coincidences, with a composite probability of 25 millionths. Gravitational deflection at perihelion is 16.4, double the jet opening. A plume composition, rich in nickel but low in iron, resembling industrial alloys. A plume containing only about 4% water, far less than typical comets. Extreme negative polarization, unparalleled among known comets. Physical properties indicating a nucleus more massive than muon MU, yet moving quicker, strange characteristic for a casual interstellar iceberg. Brightness and coloration exhibiting rapid clearing and appearing bluer than the sun near jet alignment and collimation presenting new anomalies as described by Liu. The necessity for extreme thermal isolation to sustain active ice pockets at the poles is crucial. Liu's statistics are striking in their straightforwardness. The probability that the axis aligns with our solar system's star within 8 is about 0.5%. The dual combination of events before and after perihelion yields a value of approximately 25 millionths, raising the coincidence argument to a highly improbable level. Other coincidences, such as alignment with the wow signal and meticulously timed arrivals, further diminish the likelihood of purely natural explanations. The classification scale utilized by Liu for interstellar objects as either natural or artificial indicated that prior to these new analyses, Atlas scored high, approximately between 7 and 8, where 8 signifies strong evidence of artificiality without ambiguity. The crux of the matter is that these ratings evolve with incoming data, and Liu's findings signal ongoing updates as more observations come in. What I can assert, with caution but without naivety, is that today we have a converging array of evidence and dynamic behavior that renders the hypothesis of a mere regular comet quite unsatisfactory. Science is a method. Bold theories demand robust proof. Liu and colleagues assert that the probability of coincidence is minimal. The responsibility now lies with spectroscopy, forthcoming images, and coordinated data. Should we confirm technological signatures, we would be witnessing one of the most momentous scientific events in modern history. If not, we will still acquire invaluable insights regarding exotic cometary processes. In either scenario, this case merits the utmost objective scrutiny and minimal bias. Please share your thoughts. What do you make of these coincidences and probabilities? Stay tuned for future updates. January holds the promise of more data. Let's engage in thoughtful discussion in the comments with a cool head and active curiosity.